Hey guys, so today I will be reviewing chapter 1, identifying the four types of matter and chemical and physical changes, as well as going over laws, theories, hypotheses, um, experiments, and models as well. So this is Introductory Chemistry at Mineral Area College. So I have four examples today for the four types of matter. The first one is graphite. Graphite is made out of carbon only, so that gives you a big hint. But right there, carbon is an element on the periodic table, and it may look like a heterogeneous mixture at first, but it's actually going to be an element because it's only made out of carbon. It has a hexagonal structure. It's kind of comparable to a diamond in the sense that, a diamond is only made out of carbon, and we know that a diamond is an element. It's just, graphite and diamonds are different forms or different sort of like shapes of what carbon can be. Next one is table salt. Table salt is NaCl, so that gives you a big hint right there. It's two elements, sodium and technically chloride in its ionic form, uh, bonded together, and it's making NaCl, which is a compound because it's two elements together. Another compound, a common one would be H2O or CO2, carbon dioxide. The next one, I have a trail mix, which is going to be a heterogeneous mixture because it has raisins and M&Ms and nuts, and it's multiple components, and it doesn't have like a uniform appearance. Next one is air. Air has compounds such as carbon dioxide and water, and it also has elements such as oxygen and nitrogen and more. And so it's already a mixture because it's a mixture of compounds and elements. And since air is uniform throughout, I can't just hold up my hand and be like, oh, right there is carbon dioxide, or oh, right there is going to be a water molecule. I can't be like that, right? Because air is just uniform throughout. So it's going to be a homogeneous mixture. Next, I have 8 examples of physical and chemical changes. The first one, it's also known as a combustion reaction, which you guys will learn later down in the unit. But anytime there's like a reaction going on, then it's most likely going to be a chemical change. And we also know this because we have CH4 over here on the reactants, but it's nowhere to be found in the product, so we can assume that it's a new substance now. The C from the CH4 is now going to be part of the carbon dioxide, the hydrogens are going to be part of the waters, etc. So we can just assume that it's going to be a chemical change. Next one, it's going to be a physical change because it's just carbon dioxide on both sides. It's changing from solid to gas only. And so that's just an indicator of sublimation. And a phase change, a simple phase change, is just an indicator of a physical change. Shirt is bleach. Now, this might be a little tricky, but if you think about it, if you can reverse a process, then it's going to be a physical change. If you can't reverse a process, then it's going to be a chemical change. And since whenever you bleach a shirt, it's a permanent color, you can't reverse it at all, it's going to be a chemical change because it's a new substance. Same with whenever you're permanently dyeing your hair, it's also going to be a chemical change because you also can't reverse that process as well. You might be able to keep on dyeing your hair the same pigment as your natural hair color, but in a sense, you're just keep on adding more pigment, you're not getting that sort of like natural material of your hair, right? And number 5, we have water on both sides. It's just transferring from liquid to solid, so we can understand that this is just, it's just freezing, right? Water is freezing, turning from liquid water into an ice cube. And it's just the same thing as number 2, and it's just going to be a physical change. Glass is broken. This one, just think about like a glass vase. If I break it and I kind of piece it all back together with glue or something like that, and or another adhesive, is it going to have the same properties as it whenever it was broken? In a sense, yes, it will. It's still glass. It's still made out of glass. It's still the same material. It's still transparent. It's still shiny. And whenever I piece it back together as a vase, I can still put water in it. I can still, put plants in it and things like that. So it's still glass throughout. It still has the same properties. No odors or no permanent hair color. Not permanent hair color. No odors or permanent colors were prevalent in like the process of it being a physical change, right? Vegetables are steamed. Vegetables are steamed is going to be an example of a chemical change because anytime there's going to be any cooking, steaming, or baking involved, you can just assume that it's going to be a chemical change because it's not the same substance anymore, right? So if I go to Walmart and I get some really like hard green beans and then I steam it up, it's going to be really loosened. So it's like structure, it's going to be, it's different. It's a different substance now. I can't really reverse it, right? I can't make it the green beans hard again or the material that it used to be. Eighth one is a little tricky. This is just going to be oxygen transforming into the chemical formula for ozone layer. And so this is going to be a chemical change simply because you are able to kind of breathe in oxygen. You know, that's one of its properties. But with the ozone layer, you can't really breathe in the ozone layer. It's only there just to protect us from the UV rays from being burnt to crisp. And so that's the only purpose, and that's how I think about it. And so oxygen and the ozone layer are just completely different substances, okay? And that's actually one of, I think, our homework examples. So it's just something to remember. Next, I have examples of law, theory, model, and experiment. A blank summarizes the facts and general statements through mathematical equations, data, physical representations, etc. Physical representations is a big hint that it is going to be a model because, you know, whenever I say like, oh, I want a physical representation of the solar system, then I just want a model of the solar system, right? And it summarizes facts into general statements in the sense that, for instance, if I say like Mercury is the closest planet to the sun, and then Neptune and Pluto, those are like the furthest planet of most. They're like the most further planet out into like the solar system. It's away from the sun. Then to summarize those facts into general statements, I can use a model, and the general statement would be, okay, there are planets that are over around the sun. Okay, just think about it like that. So a model is just going to, either be through mathematical equations, data, or physical representations, which I think physical representations like make the most sense, right? And so number two, an initial attempt to explain why a law exists is going to be a hypothesis. So you might have been confused between theory and hypothesis. Well, keyword here is initial, and so a hypothesis is always going to be like an almost like if-then statement. And a theory is more of like a conclusion or your proposal at the end after your experiment. And so keyword here again is going to be initial. Procedures carried out to study some phenomenon are called, this one's pretty obvious, it's going to be an experiment. An experiment has procedures. It's going to have steps in order to get to your answer. True or false, a law explains behavior and a theory states a measurable relationship. This one is actually kind of tricky because if you think about it, it's backwards. A theory explains behavior and a law states a measurable relationship. And that's from our notes too. So it's going to be false. And when I mean a measurable relationship, I mean, things like the law of conservation of mass, which state that a mass cannot be created nor destroyed. It's like here for number 8, we have 6 O's on the reactants and we have 6 O's on the products, and so it's a measurable relationship. It must be 6 and 6 on both sides because that is just the law of conservation of mass. Thank you for watching. If you have any question, please feel free to email me because I know chemistry can be confusing sometimes, but I have a couple of tricks to do really well in this class. So